Hello students, welcome to analysis of indeterminate structure class. Last class we solved or we are solving the problem by moment distribution method. Second problem we are solved. This is the continuation part, the second problem by moment distribution method continuation class it is. Yes, where we stopped last class in the calculation of moment distribution. Yes, you can once again recall that last steps. Okay, these are we are calculated the factor distribution factor for member BA, BC and CB, CD. After calculating this distribution factor, you can take these values to moment distribution table. Okay, like this you can write down the moment distribution table, joint A, B, C, D and member AB, BA and BC, CB and CD. Okay, like this. Here you can write these are the member. And next, distribution factor. Distribution factor we already calculated. You can write the factor here. On and after, we also calculated fixed end moments. And according to the member, you should write down the fixed end moments. For fixed end moment AB is minus 67.22. and fixed end moment PA is 96.11 and fixed end moment BC is equal to minus 29.7. like this you can write. After release, see here where it will come release, why it comes here. See, according to the load condition, when we are going to release, when the end support is, if the end support is simple or hinge or roller, then see, that is the condition, that is the reason here put it star. You can observe here, that is the reason. But here in our problem is the end support is hinged. So in this condition you can take the moment, or you can there where in the joint A the joint support condition is hinged, so there not occurred any moment, so we should remove the moment. That means how it possible? You can add whatever fixed end moments are you got. For that opposite sign you can add the moment. That means minus 67.22 kilonewton meter answer you got. So for this you can add the 67.22 fix for in the release condition. Okay, if you are going to release this moment, the 50% moment you should shift to next or next joint. Okay, 50% means 67.22 divided by 2. Okay, you can carry over like this towards next member. Next member is here BA. Okay, it is clear. This is one of the important step in the according to the support condition. If the support condition is end support, especially end support is simple or hinge or roller, then you should release the moment. Whatever moment created by calculating fixed end moment, you should release the moment and carry over the 50% of moment towards next or near joint. Okay, after completing this release and carry over, next is initial moments. How we are going to calculate this initial moment? You can add all the moments. That means if you are going to adding these, you will get 0. Next you can add these 96.11 plus 33.67, you are getting 129.72. Similarly add these vertical moments. Okay, here there is no any adding, just you can take this moment. Next is, after the procedure is same, whatever we did for first problem, the same procedure here we can follow. Yes, after getting this moment, the next step is balance. How we are going to balance? We are going to add these both the moment, and after changing the sign we are going to multiply with distribution factor. That you already know. It is correct. We are going to add both the moment. That means 129.72 minus 29.7. You are getting one answer. After you can change the sign, opposite sign, and multiply with distribution factor, you are getting minus 45. Similarly here also you are getting minus 55.01. Okay, similarly you are here also you are getting 8.7 and 0. After carry over the moment near joint, or like this you can carry over. Yes, here in the time of carry over, the support condition will act according to the support condition. You can observe the support A, B, C. A is hinged, B is roller, C is simple support. On that basis, here whatever moment created on roller and hinged, their moment does not carry for near member. But here joint C is or support C is simply supported. So here joint C is simply supported. So that is the reason here you should carry over the 50% moment. But here not needed. Why? The support condition is roller. Okay, you should remember this concept. And similarly here also, after completing this carry over, again you can repeat the procedure. After for this carry over moment, you can add the moment and change the sign convention and multiply with distribution factor. That means here you are getting minus 4.35 into distribution factor, multiplying with distribution factor 0.45, you are getting minus 1.95. Similarly here also. Okay, after according to the load condition, here does not carry any moment, so it is 0, 0. Finally you should add all the vertical column moments, and you are getting this answer. These are the final moments. Okay, and here very important is, here I am not going to explain the shear force calculation, that means the reaction calculation, because the same problem we did in the slope deflection method also. So you should refer those problem and the calculation part all are same. Okay, only the moment calculation step, the steps are different. Okay, you should remember this. But in the problem solving and in the exam, you should solve all the steps. That means you should calculate the reaction and draw the shear force diagram, and also bending moment diagram and elastic curve. Here I am not wrote because of the similar, whatever steps are similar. So that is the reason I am not explaining once again the same thing here, but it is very important. Okay, for calculating moments are very important because the steps are completely different. Comparing to slope deflection and moment distribution method, steps are some steps. Okay, but calculating fixed moment step is same. Okay, this is the advantage in this subject. If you are understanding in first one module, you are getting bonus, that means extra steps, the similar steps you are getting other module also. Other module means another method. Here actually the one method is one module, that means slope deflection method is one module and moment distribution method is one module, and next will come Carney's method and matrix method, like that. The one method is one module, but some steps are similar in all the module, so those steps I will skip. Okay, thank you, happy learning.